The last type of dimensional analysis problem we're going to look at in this unit is using dimensional analysis to solve three variable equations. Now, sometimes our unit is what we call a derived unit, which means it is something per something. Density, for example, could be in grams per milliliter, or concentration could be in moles per liter. Our rate or our speed could be in meters per second or kilometers per hour. So anytime we have one of these derived units, we're still able to flip it. So if I were to say, for example, something had a density of 2 grams per milliliter, that could become a conversion factor that is either 2 grams over 1 milliliter, or we could be using 1 milliliter over 2 grams. We're able to flip it based on our needs. So we're going to do a few different example problems that use these type of conversion factors. So first question says, what is the volume of a pure silver coin that has a mass of 14.2 grams? The density of silver is 10.5 grams per centimeter cubed. So hopefully we know the density is mass over volume. So my conversion factor here is 10.5 grams equals 1 centimeter cubed. Okay, so identify the units we need to convert. Essentially, we are getting from grams to centimeters cubed. So I did my step 1. Find the unit identity. My unit identity is 10.5 grams equals 1 cubic centimeter. Now set up the problem with the given as a numerator. So I'm going to start, even though this gives us 2 numbers in the problem, anytime we have a something per something, when we have one of these derived units, we're always going to start with the lonely unit because we use this derived unit as our conversion factor. So I'm going to start with my 14.2 grams when I set up this problem. Now we're going to build conversion factors that cancel out the given units. So if I have 14.2 grams, I'm going to put grams on the bottom. And we are now trying to get to centimeters cubed. According to my density, every 1 centimeter cubed has a mass of 10.5 grams. So my grams cancel, and I'm going to multiply through. So I have 14.2 times 1 divided by 10.5. So I'm going to get that the volume of a 14.2 gram sample is about 1.35 centimeters cubed. So my units are correct. I ended at centimeters cubed. That is my unit for volume here. And my other units canceled through. Does my answer make sense? Well, if 10.5 grams is about 1 centimeter cubed, a mass that's slightly higher is going to have a volume that's slightly higher. So yeah, my answer does make sense. Now, I know how much everyone loves word problems, so I decided we're going to do an example word problem here. A student masses exactly 50 grams of sodium chloride and dissolves it in enough water to make a total of a 1 liter homogeneous solution. Ooh, nice homogeneous, a mixture that is the same throughout. The experiment calls for 7.25 grams of aqueous sodium chloride to be added to the reaction. How many milliliters should they measure out? Oof, this problem has a whole lot of parts. So I'm going to start where we have 50 grams in 1 liter. So 50 grams is equal to 1 liter. Because if we look at this, this is my concentration. I have 50 grams per 1 liter. So normally we would look at it and it would look like this. Okay, concentration could be moles per liter or grams per liter. So this right here is looking like our conversion factor. The experiment calls for 7.25 grams. So I need 7.25 grams. How many milliliters? So first, we're going to identify the units we need to convert. So we just dissected this a little bit. So we're going to go from grams to milliliters. Okay. We're starting with where we need 7.25 grams, and I have to know how many milliliters I'm going to measure out. Find the unit identities. Well, I know that 50 grams is equal to 1 liter. So that'll get me from grams to liters. And if we do our metric conversions, I can also tell you that 1 liter is equal to 1,000 milliliters. So I can get from liters to milliliters. All right, so we found our unit identities. 50 grams is 1 liter, and 1 liter is 1,000 milliliters. So our next step is to set up the problem with the given as a numerator. So I'm going to start with that 7.25 grams. And 50 grams, so grams on the top, grams on the bottom, is equal to 1 liter. However, in this problem, we want to get from liters to now milliliters is what they're asking me for. So I'm going to continue my chart. And I know every 1 liter is equal to 1,000 milliliters. And in looking at this question, once again, my liters are going to cancel. So we are going to do 7.25 times 1 divided by 50 times 1,000 divided by 1. To find out that you would need 145 milliliters.